Right. So as a part of preparation of essay 2 examination, and we we have selected some questions which are very important for essay 2 examinations and are quite repeatedly asked in the previous board papers. So uh, సో అందులో భాగంగా ఏంటంటే మనం 5 మార్క్స్ క్వశ్చన్ చూసుకున్నట్లయితే ఫస్ట్ ఆఫ్ ఆల్ మనకి ఎస్ఏ 2 సిలబస్లో మనం ఇచ్చిన బ్లూ ప్రింట్ పరంగా చూసుకున్నట్లయితే సర్కిల్స్, ఏరియాస్ రిలేటెడ్ సర్కిల్స్, రియల్ నెంబర్స్, స్టాటిస్టిక్స్, ఇలా మనకి 5 మార్క్స్ నుంచి ఏ చాప్టర్స్ వస్తాయో మనము డిసైడ్ చేసుకున్నాం. అయితే 5 మార్క్స్కి ఆ చాప్టర్ నుంచి ఏవి రావడానికి అవకాశం ఉంది, ఏవి ఎక్కువ అడిగాడు అని మనం ఒకసారి చూసుకున్నట్లయితే ఈ విధమైన క్వశ్చన్స్ ఎక్కువసారి అడిగాడు అనమాట. రైట్. ఇన్ ఫిగర్ a circle touches all the four sides of quadrilateral ABCD. టచింగ్ అంటే ఖచ్చితంగా అదేమవ్వాలి, సర్కిల్కి టాంజెంట్ అవ్వాలి. ఇఫ్ AB ఈజ్ ఈక్వల్ టు 6, BC ఈజ్ ఈక్వల్ టు 9, CD ఈజ్ ఈక్వల్ టు 8, then find the length of AD. We have to find length of AD. Now, if the same question is asked for 2 marks, we can directly tell the answer, we can directly solve the answer by using a property: sum of opposite sides are equal. If a circle is inscribed in a quadrilateral, then by default sum of opposite sides are equal. That means AB plus CD should be equal to BC plus AD. So I'll write that for if it's asked for 2 marks. Given circle inscribed in a quadrilateral, if a circle is inscribed in a quadrilateral, then automatically sum of opposite sides are equal. So therefore AB plus quadrilateral ABCD. Okay, so AB plus CD should be equal to BC plus DA. Okay, then we can directly substitute the values. So AB is 6 plus CD is 8 is equal to BC is 9, and DA we have to find it as X. So 14 is equal to 9 plus X. 14 minus 9 is equal to X. 5 is equal to X. That means X is equal to 5 centimeter. In this way we'll solve the problem. But what if he asked to find or to prove this thing? Okay, to prove. So same question ఎలా అడుగుతారంటే, a circle is inscribed in a quadrilateral, prove that AB plus CD is equal to BC plus DA. We have to prove AB plus CD is equal to BC plus DA. Okay, now since AB, AD, CD and CB are touching the sides of the circle, so they will be the tangents, right? Okay, so since the sides AB, BC, CD and DA are touching the circle, so by default they will be tangents. So touching the circles at, we can write AB ni manamu oka point P anukundam, point of contact BC Q anukundam, CD R anukundam, and DA manamu S anukundam. So at P comma Q comma R comma S. So since the sides AB, BC, CD and DA are touching the circles at P comma Q comma R comma S, they will be tangents. So therefore we know that from theorem 10.2, two tangents drawn from an external point. Two tangents drawn from an external point are always equal in length, so therefore from figure AP is equal to AS, right? AP is equal to AS. Similarly, BQ is equal to BP. We will write all vertical things on one side, horizontal things on other side. So we can write BP is equal to BQ. But ఇక్కడ AP మనకు horizontal, BP కూడా horizontal కాబట్టి ఇక్కడ BP రాస్తాను నేను. BP is equal to BQ. Similarly, CR is equal to CQ. CR is equal to CQ. And DR is equal to DS. DR is equal to DS. Okay. Now adding on both sides, it will become AP plus BP plus CR plus DR is equal to AS plus BQ plus CQ plus DS. And AP plus BP is nothing but AB. So AB plus CR plus DR is CD is equal to AS plus DS. AS plus DS is nothing but AD. And BQ plus CQ is nothing but BC. So therefore AB plus CD is equal to AD plus BC. AD plus BC. That's what we have found. AB plus CD is equal to BC plus DA. AD plus BC. Okay, so and this is how we'll prove it. Okay, so if it is asked for 5 marks, we have to do this and then we have to do this problem. And the same question is asked for 2 marks, we can directly do the problem by applying this theorem. Okay, now what is the same question is asked in different way? Prove that the parallelogram circumscribing a circle is a rhombus. Okay, same. Let ABCD be a parallelogram. ABCD be a parallelogram. So it is a circle. We have to prove that this ABCD is a rhombus. Okay, now it is touching a different point, so let me draw with other color. P Q, the same what we have done in the earlier problem, the same thing is follows. So let ABCD be a parallelogram. So to prove ABCD is a rhombus, ABCD is a rhombus, given ABCD is a parallelogram circumscribing a circle, circumscribing a circle. Now the first thing is, since ABCD is a parallelogram touching the circle, okay, so ABCD is a parallelogram. ABCD is a parallelogram touching the circle at points of contact, P, Q, R, S. P, Q, R, S. So from figure we can tell that AP is equal to AS, right? AP is equal to AS, and similarly BP is equal to BQ. Similarly CR is equal to CQ and DR is equal to DS. Why? Because two tangents drawn from external point, two tangents drawn from external point are always equal in length, are always equal in length. Two tangents drawn from external point are always equal in length. So therefore AP is equal to AS, BP is equal to BQ, CR is equal to CQ, and DR is equal to DS. Now adding on both sides, so that will become AP plus BP plus CR plus DR is equal to AS plus BQ plus CQ plus DS. So now AP plus BB is AB and CR plus DR is CD is equal to AS plus DS would be AD and BQ plus CQ will be BC. But since it is a parallelogram, opposite sides are equal, right? So therefore AB will be equal to CD and BC will be equal to AD, because given ABCD is a parallelogram. Since it is given parallelogram, so we can directly substitute AB is equal to CD. So that will become CD plus CD is equal to BC can be written as AD. So AD plus AD. So 2CD is equal to 2AD. So 2 gets cancelled. So therefore CD is equal to AD. If CD is equal to AD, AD is something equal to BC, and CD is already equal to AB. So therefore all four sides are equal, and parallelogram have unequal diagonals. So if all four sides are equal and diagonals are unequal, then ABCD will be a rhombus. Therefore ABCD is a